I want to show you how the input of a SMPS power supply looks like. Now, this is the live from the supply, and this is the neutral from the supply. This live from the supply is connected through this resistor, and this resistor is for current suppression. The output of this resistor is connected to this bridge rectifier. You can see these 4 diodes here. These 4 diodes are forming a full wave bridge rectifier. So this full wave bridge rectifier is used to rectify the input voltage into DC. After rectification, there is this smoothing capacitor. I will show you about the capacitor. After the capacitor, there is this discharging resistor. I will also show you about the resistor. So this is how the full wave bridge rectifier looks like. As you can see, these 4 diodes, they are silicon diodes which are arranged in a circuit that is forming 4 arms. A bridge is an electrical circuit with 4 arms. So this is how the bridge looks like. There is this diamond shape, and then all the diodes are facing the right hand side. This is our first diode, our second diode facing the same direction, our third diode facing the same direction, and our 4th diode facing the same direction. This is how these 4 diodes are arranged. And then the live from the supply, it is here. This is live from supply. And the neutral from the supply, it is here. This is the positive terminal of the output, and the negative side of the output for the bridge rectifier is here, as you can see. The AC input here looks like this. Mostly is 240 VRMS. We are going to measure the input here and see what the input is for the bridge rectifier. You have to be very careful because you are dealing with high voltage here. Don't mess or do anything you are not sure of. So I'm going to set my multimeter to AC voltage, a range of 600, and measure our input voltage. Our input voltage is 248. Our input voltage is 248 volts. This input wave will be rectified, and the output here, we can measure our output in these terminals, which will be given by V peak, which we can also call it the DC voltage, which is given by √2 times V RMS, which will be our output. VDC will be given by √2 times 248 volts. That should be the output of this bridge rectifier, 350 volts, which is a very high voltage. You should be very careful when handling this. I'm going to measure. You can see the output of this circuit is between this terminal. You have to be very careful so that you don't short your probes. It is between that and this terminal. You can see our output is around 350 volts DC. This output of the bridge rectifier looks like this. The output waveform looks like this. The DC output waveform looks like this. So here there is this capacitor. You can see this capacitor. It is connected here in series with the output. The rectified waveform looks like this. When we pass it through the capacitor, when the wave is rising, the capacitor will store energy. When the voltage is dropping, the energy in capacitor is released like this. So it does not go back to zero. The ripple does not go back to zero. During the rising of the voltage, again, the capacitor stores energy. During the falling of the wave, the capacitor releases the energy stored, so that the wave does not fall again to zero. Again, during the rising of the voltage, which is the rising of the voltage, the capacitor stores energy, and this energy, the capacitor releases the energy when the voltage is dropping, so that the voltage does not go to zero, and this continues like this. This is what we call ripple. This is what we call the ripple. This is the ripple. Now it comes from 0 to 350 VRMS. The voltage is changing from 0 maximum, 0 maximum, 0 maximum. But now, after this capacitor, the waveform will be looking like this. It will be like this, which will reduce the ripple. Will reduce the ripple so that the ripple does not move from 350 volts to 0. It is moving from 350 to something lower, which could be 340, 333. So the output ripple is reduced. So the capacitor is used to filter this ripple so that the voltage does not vary from 350 VDC to 0. So after the capacitor, this is the voltage now. Again, after this capacitor, we also have a resistor here, and this resistor is called discharging resistor. This is the resistor that uses the energy in this capacitor when you switch off your power supply. So this is what happens when this wave is racing. When this wave is racing, this terminal will be more positive compared to the neutral terminal, and the current will flow like this. Current will flow like this, past this diode, come here, pass through the resistor, the load resistor, and then get back like this, pass through this diode, and get back to the supply. That is during the positive half cycle. That is when the AC is in the positive half cycle, like you can see. During the negative half cycle, which I mean this one, during the negative half cycle, the neutral is more positive compared to the live, and current will flow from here, following this dotted line via this diode like this, come to the load, and flow again back like this, get back like this, and it reaches here, it will pass like this, and it will go like that. So that is how the input of an SMPS power supply looks like. Thank you very much.